Good morning everyone. Welcome back to NEET World. So today we will be discussing the continuation to the last session, that is mole concept and its interconversions and its applications also. Okay. So in the last class I have given you some questions here. Let us quickly revise this and then next we will start our discussion of its application also. Okay. So in the manam last class lo mole concept interconversions and వాటి యొక్క యూసేజెస్ తెలుసుకున్నాం కదా. సో ఈరోజు కూడా వాటిపైన కొన్ని క్వశ్చన్స్ చేసి అండ్ వాటి యొక్క ఇంకొన్ని అప్లికేషన్స్ కూడా నేర్చుకుందాం. సో ద ఫస్ట్ క్వశ్చన్ హియర్ సేస్ సి 5.6 liters of a gas at STP weighs this much grams. So what it can be, what is a possible gas out of these four options? Even the same question I have discussed in the last previous class also. Okay, if you haven't watched that session, I kindly suggest you to watch it. Okay, again we'll be explaining this. Just listen here. 5.6 liters of a gas at STP. Okay, so any gas at STP, if we are taking as a 1 mole of quantity, then that will occupies 22.4 liter. So 1 mole of any gas, 1 mole of a gas at STP. Yesterday I have clearly discussed about this. At STP, what do we mean by STP? Standard temperature and pressure. Like temperature should be 0 degrees Celsius or 273 Kelvin and pressure should be 1 atm pressure. So at these conditions, 1 mole of any gas you take here, okay, consider it as an ideal gas. Okay, so that gas will occupies 22.4 liters of volume. Okay, how much? 22.4 liters of volume. So if you consider 1 mole of oxygen gas at this STP condition, how much volume it will be having? 22.4 liter. So not only oxygen, you consider any of the gas at this STP condition. If you are taking a 1 mole of that gas, what is the volume it will be having? 22.4 liter. Okay, so now read the question. So 5.6 liters of a gas at STP weighs this much. So which gas can be out of these four? They are saying. So it is simple. So now volume they have mentioned now. So from that you find number of moles of that gas. After finding number of moles, now take the given weight by molar mass of that substance. That's it. So this gives you which gas exactly it is. So 5.6 liters now. So I told you the formulas also. How can you convert given volume into number of moles? So number of moles from the volume will be volume given at STP by 22.4 liter. So this gives you what? So this gives you number of moles. This should be in liters. Okay, so the given volume is how much? 5.6. okay, and 22.4 in the denominator. So this will be 1 by 4 liter. So how many moles it is? 1 by 4 mole. So number of moles of this gas will be now 1 by 4. After getting number of moles, find molar mass. So if we find the molar mass, then our answer should be done here, because by finding molar mass we can able to know which gas it is. So how can I find molar mass? You just send molar mass here, number of moles here. So given weight by number of moles. So what I can take? Given weight is, see in the question they mentioned given weight as 4.25. Number of moles how many we got? 1 by 4. So 1 into 4 you can write like this. So this will be around 17 grams. Okay, so 17 gram per mole. This is the molar mass. So which of these gas is having 17 gram per mole as a molar mass? Tell me. So here if you observe, nitrogen and 3 hydrogens are there. Nitrogen is 14 grams. Okay, and 3 hydrogen, each hydrogen is 1. So the total sum is how much? 17. So what is our suitable answer for the discussion? First answer. Okay, next go with the other options also. See, this is O2 now. Oxygen molar mass is how much? 32. So 32 is not our answer here. It is only 17. So you can verify for this also. So carbon, 2 carbons are there, 2 into 12 plus 6 hydrogens are there, 6 into 1. So 12, 24 plus 6, 30. So this is also not our option. So even this is also not our option. So only first one is our perfect answer for the discussion. Okay, like this. Let us go with the next question also. See what the question says: maximum number of molecules are present in. See they have given this much quantities, like 5.6 liter of CO2 at STP. See 5.6 liters means how many moles? 1 by 4 moles we got here. 1 by 4 mole you can say. okay, and this is the weight is given. From that you can find number of moles. How can you find number of moles? Given weight 15 by what is the molar mass of CO? So carbon 12, oxygen 16. So total is how much? 12 plus 16. So it will be 28. So take here 28. Like this you find number of moles first. Okay. So 1 mole contains Avogadro number of particles. What do we mean by Avogadro number? 6.022 into 10 power 23 particles. Like this na. So find 1 mole, how many moles, first find how many moles, multiply with Avogadro number. So it is simple, more the number of moles, more will be the molecules. More the number of moles, more will be the molecule. For example here, how many moles we got? 1 by 4 mole we got na, multiply with that Avogadro number. Okay, like this for every option you need to calculate the number of moles first, multiply that with Avogadro number. So greater the number, greater will be the molecules. So for this you check how many moles it will be. So the given weight is 4 grams and molecular weight or molar mass of hydrogen is 2 into Avogadro number. So it means, see, 2 into Avogadro number we got. So as of if we consider all these things, we have only maximum number of molecules here in option 3. Why? Because 2 into Na, number of moles are 2. In all other cases number of moles are less than 1, but for third option only it is 2. So it means perfect answer for the discussion is third option. Okay, so I hope this is also clear. Ardhamaindi anukunta, ardham kakapothe you can mention in the comment box. I will discuss it once again. Okay, ardhamaindi kada. So next let us move forward. Okay, yesterday I have explained these 2 questions. If you haven't watched, please go through it. Once try these 2 questions. If you are unable to solve, watch that. Okay, next let us move forward. So the next concept is percentage composition. So what do we mean by percentage composition? We have a, generally we will see a basic questions in these. Okay, and this is very important to understand also. See, what do we mean by percentage composition? Means, let us say there is a methane molecule. What I am saying, in methane molecule, what is the percentage of carbon? What is the percentage of carbon? Or what is the percentage of hydrogen? What I am asking, what is the percentage of carbon or what is the percentage of hydrogen? Like this they will make a question. Okay, so it is very simple. There are 2 things, percentage of carbon or hydrogen. Like this, if I ask, what you need to take, either weight percentage or mole percentage. If they are not asking anything particularly, consider it as a weight percentage. So percentage, weight percentage of carbon if I say, so what does it mean? Means weight of that component. Which component we are talking about? Carbon component, no? So weight of component C, carbon, by total weight. Total weight of the compound, total weight of the compound, total weight of compound into 100. So let us say in methane, so I am asking what is the percentage composition of carbon. Okay, what you will do, tell me, what is the weight of carbon? Here you need to check. See, what is the molar mass of carbon? So for molar mass of carbon is 12. For hydrogen is 1 into 4 hydrogen. So it total sum will be 16. So ఇప్పుడు ఏం చేయాలి అని అంటే, what is the weight of carbon we have here? So 12, take it in the numerator. And total weight is how much? Total weight is, for the molecule total compound weight is 16. So take that in the denominator into 100. That's it. You are done with the question. So this will be 3s are, 4s are, this is 25s are. That's it now. So 3 into 25, 75%. So what is the percentage of carbon in the methane molecule? It is 75%. Okay, right. Now the question can also be asked for calculating percentage of hydrogen also. So what you can do here, so what is the weight of hydrogen in the numerator? See, whatever they are asking in the question, take that in the numerator, and total weight in the denominator, multiply with 100. That's it. So this is what you need to do here. Okay, so now tell me, percentage of hydrogen means what you can take? Weight of hydrogen. See, in methane, what is the weight of hydrogen? We have 4. So take here 4. And what is the total weight we got? 16. So total weight 16 into 100. That's it. So this will be 4 times. This will be 25 times. So what is the percentage of hydrogen we got? 25%. Carbon 75%. Total 100%. That is how you need to do it. Okay, right. Now let us do it for carbon dioxide. Okay, now I am asking what is the percentage weight of carbon, what is the percentage composition of carbon. So what you need to take here, percentage composition of carbon means weight of carbon divided by total weight of compound. What is the total weight of compound? You take in the denominator, multiply that with 100. Okay, done. So now here tell me what is the molar mass of carbon dioxide? It is 44, and particularly for carbon it is 12, for oxygens it is 32. Right now, so total sum is 44. That's it, done with the question. So in the denominator you take 44, in the numerator you take 12 into 100. That's it. Try to simplify this. So upon simplifying, how much you are going to get? So 4 3s are 4 11s are. So something like 300 by 11 we have. Okay, so 11 1s are 11 9s are 99. Okay, 99. So 99 means 1. So decimal we can say 10. Okay, almost this is again 99.09 something like this we will get. So upon simplifying, so it will be 27.27 percentage. What is the answer finally? 27.27. Like that you are going to get the percentage composition of carbon. Okay, now if I ask for oxygen, what you need to do? So weight of oxygen by total weight of compound into 100 you need to do. Okay, that's it. How simple it is? Yeah. Next, we can also do, see if I ask what is the percentage of oxygen here, so what you can do, so total compound percentage is 100, so 100 minus percentage of carbon if I remove, so that gives you oxygen percentage also, no? So this is also one more way we can do, but the concept should be clear to you. That is the main agenda of this discussion. Okay, now one important question, this is also asked in NEET PYQs. So the question will be like this: what is the percentage of nitrogen by weight in urea? So please do this. This is already asked in the previous exam, that's why I am mentioning. Okay, so take this as a question, as a homework, and mention your answer in the comment box. Okay, so what to do? First write the urea formula, find its molar mass, okay, and take how many nitrogens are there, that weight you take in the numerator, divide with total weight into 100. So urea formula also I am giving you here, C double bond O NH2 NH2. Remember it like this only, so that you can be familiar with the structure also. Okay, so this is the structure of urea. So percentage of nitrogen I am asking now. So how many nitrogen atoms are there? 2. So 2 into atomic weight of nitrogen, that is 14. So 2 into 14, 28, by total mass will be 60. So take that 60 in the denominator into 100. So simplify that, you will get your answer. Please let me know what is your answer in the comment box. Okay, right. Let's move forward. Yeah, let's move forward then. Yeah. So the next question and next important concept is stoichiometry and stoichiometry calculations. What is that? Stoichiometry and stoichiometry calculations. So here stoichiometry means, see, stoichion, the word here stoichion means element, elements, metry means measure. So it means during a reaction we are going to measure the elements, how much quantity of that element combining with other things to form some product. During a transformation, how that elements are participating, how much quantity they are participating, like that we are going to do in this stoichiometry and in stoichiometry calculations. Once again read this. Stoichiometry is a branch of chemistry that deals with the quantitative relationships between reactants, products in a balanced chemical reaction. For example, here for formation of carbon dioxide, like carbon undergoes combustion, forms carbon dioxide. This is a simple formula reaction we know right now. So during this reaction, first balance the equation. How many carbons are there here? 1. So this side should also be 1. How many oxygens are there? So this is 2 oxygen atoms. So here also 2 oxygen atoms. So everything is balanced. So write the balanced equation. Now it deals with the quantitative relationships between reactants and product. See, to this arrow mark, the left side here, these are called reactants, and this side is called products. Okay, now what it will do is stoichiometry gives a relation between the amount of reactants used to get a particular amount of product. That relation comes from the stoichiometric calculation and stoichiometry. Okay, right. So now how many types of stoichiometric calculations are there? Just listen to me, you are going to get complete idea on this. First, mass calculations, next mass volume calculation, mole calculation, limiting reagent concept. These are the things to be followed here. First thing is, if you observe, let us consider this as mole concept, mole relation. What is this mole relation? See, from the balanced equation, what is the stoichiometric coefficient? Here we have this beginning terms are there, na? Those are called coefficients. So what is this number? 1. Here also 1. Here also 1. So it means 1 mole of carbon react with 1 mole of oxygen molecules forms 1 mole of carbon dioxide. Once again, 1 mole of carbon react with 1 mole of oxygen forms 1 mole of carbon dioxide. Similarly, I will write here one more simple reactions. See, I don't want to make you feel stressed here. That's why I am making very small reactions first. See, it's not about big reaction or small reaction. The concept should be clear. That is the only aim first of all. Once after getting clarity, we can move for the complex reactions also. Okay, right. Look at here. How many hydrogens are there? 1 hydrogen molecule. It means 2 hydrogen atoms. Here also 2 hydrogen atoms. 1 oxygen atom. So here also it is balanced as 1 oxygen. So half into 2. So this is 1 oxygen atom you can consider if I write half O2 means. Okay, so what is a mole relation here you can say? So 1 mole of H2 combining with half mole of O2 forming 1 mole of H2. So this is what mole relation. So now what is the use of knowing these mole relations? Yeah, I will tell you one simple thing. I'm saying you to produce 4 moles of carbon dioxide in the reaction. What I am saying? You go to the lab, take the equipments and produce 4 moles of carbon dioxide. So how many moles I want? Carbon dioxide as 4 moles. In order to produce 4 moles of carbon dioxide, how many moles of carbon you should need to take? How many moles of oxygen you need to use? This is the question. Ardhamainda? Malli I am repeating the same in Telugu. See, mimmalni lab kelli 4 moles of carbon dioxide ni prepare cheyamani adugutunna. So what you are going to do? You are going to take carbon and oxygen and you will start the reaction. But how much quantity of carbon you require? How much quantity of oxygen you require? That concept comes from the stoichiometric calculations. See, look at this. As per the balanced equation, for every 1 mole of carbon dioxide, you required 1 mole of oxygen and 1 mole of carbon. It means for 4 moles production, we required 4 moles of O2 and 4 moles of carbon. That's it. This is how you need to take. Okay, let us come here. Let us look at this second example also. I want to produce here 4 moles of water molecules. How many moles of water molecules I am asking? 4 moles of water molecules I want. Then for production of 4 moles of water molecules, how many moles of oxygen required? How many moles of hydrogen required? This is what the question asking here. See, for production of 1 mole, we also required 1 mole of hydrogen. Similarly, for production of 4 mole water, we definitely required 4 moles of H2 also. Okay, see, for production of 1 mole of water, we are requiring half mole. What we requiring? Half mole of O2. So for production of 4 moles, you are going to require here X. So how can you find this X? So X into 1 equals to 4 into 1 by 2. See, from here to here, how they related? 1 means half. అంటే ఒకటి ఉన్న దగ్గర హాఫ్ అని తీసుకుంటున్నాం. 4 ఉన్న దగ్గర ఇందులో హాఫ్ ఎంత 2 అని తీసుకోవాలి. సో హౌ మచ్ ఇట్ ఈస్? 2 mole of oxygen is required. 4 moles of hydrogen and 2 moles of oxygen is required during the process. ఇలా మనం అర్థం చేసుకోవాలి. ఓకే, Now I will take you into little more deeper also, but as of now this is enough. I will make it more clear with the other examples. So more relation concept అర్థమైంది అనుకుంటున్నా. Okay, one last discussion here. నేను ఈ రియాక్షన్ జరిగేటప్పుడు when we are doing this reaction, I am giving you like this. I am giving you something like 2 moles of 2 mole H2, 2 mole O2 I am giving you. Now I am asking you how many moles of H2O is formed. అంటే రియాక్షన్ జరిగే ముందే నేను ఏమని ఇస్తున్నా, ఈసారి రియాక్టెంట్స్ మెన్షన్ చేస్తున్నా. 2 moles H2 అంటున్నా, 2 moles O2 అని చెప్తున్నా. సో హౌ మెనీ మోల్స్ ఆఫ్ వాటర్ ఈస్ ప్రొడ్యూస్డ్, ఈ రియాక్షన్లో వాటర్ ఎంత ప్రొడ్యూస్ అయింది అనే క్వశ్చన్ మీకు ఇస్తున్నా. సో టెల్ మీ హౌ మెనీ మోల్స్ ఆఫ్ వాటర్ ఈస్ ప్రొడ్యూస్డ్ డ్యూరింగ్ ద రియాక్షన్. Tell me, so yes, tell me what is your answer for the discussion? Yeah, so I hope you have tried this question now. Again, so what I am asking, by taking 2 moles of H2 and 2 moles of O2, how many moles of water is formed? Okay, let us understand this by taking here H2 plus O2 gives rise to H2O, I am saying. First of all, balance the equation. So for balancing, you take it like this, 1 half 1. Okay, so what is the stoichiometric relation we have? 1 half 1. You need to take the stoichiometry coefficients by balancing the reaction only. Okay, okay. Then next, given what they have given, 2 moles of H2, given 2 moles of H2 and 2 moles of O2 is provided. Okay, now how many moles this is forming they are asking. See, it is very simple. When you are observing the reaction, like as per the balanced equation, for every 1 mole of hydrogen, we require half mole of O2. See, for every 1 mole of hydrogen, we require half mole of O2. So similarly, for every 2 moles of hydrogen, we should require 1 mole of O2. Why 1 mole? See, for 1 mole, half mole. 2 moles, 1 mole. Why? Because it is something like a relation you take here. For every 1 mole, half of it is required. For every 1 mole, 1 by 2 is required. Then for every 2 moles, how much it is required? So if you are unable to understand that, you take how much it is required as x value. We need to find this x value. So x is equals to, how do you do is x into 1. So this is called a unitary method, x into 1. So this 2 into 1 by 2, 1 by 2 into 2. Okay, so 2 cancel, so it will be 1 mole. Okay, so since they given 2 moles of hydrogen and 2 moles of O2, but as per the balanced equation, for every 1 mole we required half mole of O2 only. Even for the 2 moles also we required 1 mole only, but the given is 2 mole. it means they have provided more than the excess quantity. So out of this 2 moles of oxygen, 1 mole will react, 1 mole remained unreacted. So I am saying unreacted now, so you can say this is a excess quantity given. Required is only 1 mole, but they have given it as 2 moles of oxygen. So you can say this is excess reagent. What type of reagent it is? Excess reagent. Okay, and this is completely consuming the reaction now. This is called limiting reagent. What is it? Limiting reagent. Okay, so understanding excess reagent, limiting reagent is most important topic of the discussion. Why? Because if something is lesser quantity, that is considered as limiting reagent. So now the limiting reagent, that lesser quantity thing will decide how much amount of product should be formed. అంటే ఈ రెండిట్లలో మనం ఎవరైతే తక్కువ ఉన్నారో వారిని లిమిటింగ్ రియేజెంట్ అనాలి. సో దాన్ని దృష్టిలో పెట్టుకొని హౌ మచ్ అమౌంట్ ఆఫ్ ప్రోడక్ట్ ఫామ్ అవుతుంది అనే క్వశ్చన్కి మనం ఆన్సర్ చేయాలి. ఓకే, నౌ లుక్ ఎట్ దిస్. ఫర్ ఎవ్రీ 1 mole product formed also 1 mole. Then for every 2 moles product formed should also be 2 moles. That is the answer. So how many moles of water will be formed? 2 moles of water is formed. And how many moles of oxygen used? Out of the given 2 moles, only 1 mole is used and remaining 1 mole remained unreacted. That is unreacted remains as excess. So consider this as excess and this as limiting, and amount of product formed is 2 moles. Okay, now the same question I am giving you as a homework by changing these numbers. So here I am giving you 8 moles O2, 4 mole H2. Then calculate limiting reagent and excess reagent. What I am asking first, limiting reagent, excess reagent, and amount of product formed. How much amount of product is formed. So this is what you need to do. Okay, so one last discussion here is about weight calculations. What do we mean by weight calculations? For example, here the same reaction I am taking, H2 plus half O2 combining to form H2O, we are discussed right now. So as per that, 1 mole of H2 stoichiometric coefficients you take, 1 mole of H2 combining with a half mole of O2 forming 1 mole of H2O. So 1 mole of H2 means what is molar mass? Find. Now I am saying about weight relation. Here it is mole relation. Till now the discussion is about mole. Now it is weight relation. అంటే ఏంటి అని అంటే ఎంత వెయిట్ హైడ్రోజన్కి ఎంత వెయిట్ ఆక్సిజన్ కావాలి, సో దట్ హౌ మచ్ వెయిట్ ఆఫ్ వాటర్ ఈస్ ఫార్మ్డ్, ప్రోడక్ట్ ఈస్ ఫార్మ్డ్. అంటే మనం ఈ క్యాలిక్యులేషన్స్ అంతా కూడా వెయిట్ క్యాలిక్యులేషన్స్ అంటే గ్రామ్స్లో క్యాలిక్యులేట్ చేస్తున్నాం అన్నట్టు. ఓకే, నౌ లుక్ ఎట్ దిస్. హాఫ్ మోల్ H2 అంటే ఎంత వెయిట్ దానికి అనేది మనకు తెలియాలి. సో ద నెంబర్ ఆఫ్ మోల్స్ ఈజ్ ఈక్వల్స్ టు గివెన్ వెయిట్ ఆఫ్ సబ్స్టాన్స్ బై మోలార్ మాస్ కదా. సో నేనేమంటున్నా అంటే వెయిట్ అనేది నాకు ఎంతనో తెలియాలి. అప్పుడు ఏం చేస్తా, ఐ కెన్ సెండ్ దిస్ మోలార్ మాస్ టు దిస్ సైడ్. సో ద వెయిట్ ఆఫ్ సబ్స్టాన్స్ విల్ బీ నో టేకెన్ యాజ్ నెంబర్ ఆఫ్ మోల్స్ ఇంటూ మోలార్ మాస్. How many moles here we have? It as 1 mole. Here it has 1 mole. So 1 into what is the molar mass of hydrogen? 2. So what is the weight? You can say 1 into 2 means 2 grams. That's it. So 2 grams of H2 combining with half mole. So half into molar mass of O2 is 32. 32 grams. Half into 32. It means you can simply write 16 grams. So 2 grams of hydrogen combining with 16 grams of oxygen and forming 1 mole of water molecule. 1 mole of water molecule is nothing but its molar mass. How much? 18 grams of water. Okay, once again 2 moles of hydrogen combining with 16 grams of oxygen forming 18 grams of water. Okay, ఇలా అర్థం చేసుకోవాలి. మనం లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ మాస్ అనే కాన్సెప్ట్ని డిస్కస్ చేసినాం, గుర్తుంటే చూడండి. So the total mass of reactants should be equals to the total mass of product formed. How many grams it is reacting? 2 plus 16 now. So 2 plus 16 means how much? 18 grams. చూడండి లెఫ్ట్ సైడ్ ఆఫ్ దిస్ యారో మార్క్ అంటే ఈ లెఫ్ట్ సైడ్ వైపు రియాక్టెంట్స్ వైపు ఎంత ఉంది 18 గ్రామ్స్ ఉంది. ప్రొడక్ట్ వైపు కూడా చూడండి హౌ మెనీ గ్రామ్స్ ఇట్ ఈస్ 18 గ్రామ్స్ ఓన్లీ. ద టోటల్ మాస్ డ్యూరింగ్ ఎ కెమికల్ రియాక్షన్ ఈస్ కన్జర్వ్డ్ ఆర్ రిమైన్స్ సేమ్ కదా. సో ఇట్ ఈస్ ఆల్సో ఒబేయింగ్ లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ మాస్ అని కూడా మనం అర్థం చేసుకోవచ్చు ఇక్కడ. ఓకే, సో నౌ వాట్ ఐఎమ్ గోయింగ్ టు ఎక్స్ప్లెయిన్ హియర్, not just this thing. See, as per this, how many grams of, as per the equation, balanced equation, how many grams of hydrogen required? 2 grams. How many grams of oxygen required? 16 grams. How many grams of product formed? 18 grams. Now listen to my question. Like this, most like here you can expect the question in the exam also. Okay, the question will be like this: when 4 grams of H2 and 16 grams of O2 reacted to form water, then identify limiting reagent and excess reagent and calculate amount of water formed. If you are clear with this one question, most of your limiting reagent, excess reagent topic is done. Okay, nothing to worry much. Okay, just taking the PYQs and solving the questions is more than enough for understanding this limiting and excess reagent concept if you are clear with this one particular discussion. Okay, right. So tell me, anyone who are watching this, please mention your answer in the comment box. Yeah, so yeah, let me explain here. Okay, so as per the equation, as per the balanced equation, we got something like this: 2 grams required, 16 grams produces 18 grams. But given question says first always write as per the equation first, understanding purpose. Then next, as per the given question you write here. So they have told 8 grams of hydrogen, you write it under hydrogen, 4 grams of hydrogen and 16 grams of oxygen they have given. Okay, oxygen they have given. Now how many grams of water molecule forming they are asking. Okay, it is very simple. See, for every 2 grams of hydrogen, how many grams we required as per the equation? 16 grams is required. Now here the given quantity is 4 grams. For 2 grams 16 grams, then for 4 grams it should be 32 grams now, because it is doubled here, this should also be doubled. Okay, but how much they provided? Only 16 grams is provided. It means oxygen is here lesser than the requirement. So you can say oxygen as a limiting reagent and hydrogen as excess reagent. Okay, like this. Okay, now what I told you, the amount of compound formed should be calculated with this less number of moles, like lesser quantity substance, which is that one limiting reagent. Limiting reagent అని ఎందుకు వాడుతున్నాం మనం? అది కావాల్సిన క్వాంటిటీ కన్నా తక్కువ ఉంది కాబట్టి దాన్ని లిమిటింగ్ రియేజెంట్ అంటున్నాం. సో ఇది కావాల్సిన దానికన్నా తక్కువ ఉంది కాబట్టి సో దట్ విల్ డిసైడ్ హౌ మచ్ అమౌంట్ ఆఫ్ ప్రోడక్ట్ షుడ్ ఫామ్ అనేదాన్ని. ఓకే, సో చూడండి మనకి ప్రతి 16 గ్రామ్స్కి ఫర్ ఎవ్రీ 16 గ్రామ్స్ we required 2 grams only, but here for the given 16 grams they mentioned 4 grams. So it means out of 4 grams only 2 grams will be reacting with this oxygen and 2 grams remains excess. 2 grams remains excess. Out of 4 grams of hydrogen only 2 grams will react and 2 grams will remains excess. Okay, now 16 plus 2. So what is the amount of product formed? 18 grams of water is formed. Okay, so now you got to know identifying limiting reagent, excess reagent, calculating the answer product formed with respect to limiting reagent. Right now, see, for every 16 grams you are going to get 16 here, 16 there. Okay, so like this. So amount of reactants unreacted is how many grams? 2 grams. Okay, like this you need to calculate. So one last question as a homework I just wanted to mention for the same discussion. See, instead of taking the question as 4 grams of H2, I just want to modify this question number like this. Instead of taking this 4 grams, you take question and tell me what is your answer. Take this as 8 grams of H2, okay, and this one here as 32 grams of O2, 32 grams of O2, or can take it as 64 grams of O2. Then tell me what is limiting reagent, excess reagent, amount of product formed and amount of reactant remained excess. Okay, so this is all the discussion about limiting reagent and excess reagent calculations and all. The remaining things we will be discussing in the upcoming sessions. Okay, so if you like the content, please hit on the like button and you can share with your friends who are completing the 10th class and moving for 11th and 12th. Okay, and even if you are a class 11th student or 12th students who are preparing for NEET or EAPCET JEE exams, these sessions are highly useful. Okay, can share with all your friends who are preparing for those exams. And if you are really interested in our offline centers or any online batch, you can reach us directly to the mobile numbers given in the description box. So thanks for watching. Stay connected.